So first of all, I'm not going to do all of this by hand for you. It takes a lot of time. So if you are not here or you're watching this recording and you want to know what the solution is to this, check the key on OneNote under Unit 5, Statistics, Shapes of Distribution. So let's check that now, actually. I'm going to continue this record here. There we go. Okay. This reinforces what I just talked about here, this visual. We call that end the tail, right? So here, the tail of the graph extends to the left. The tail of the graph extends to the right. Most of our data is to the left, while the tail is to the right. Most of our data is to the right, while the tail is to the left. Here, this visual. Do we have questions? We call that end the tail. Pretty straightforward, I hope, right? So here, the tail of the graph extends to the left. The tail of the graph extends to the right. Most of our data is to the left, while the tail is to the right. Most of our data is to the right, while the tail is to the left. Do we have questions? Pretty straightforward, I hope. So for the sake of time, because I didn't know how long that first activity would last, I have a frequency table. They gave you the intervals super easy. You're just drawing it. Now, looking at the distribution of this data, how would you say that it's skewed? Yeah. So if you were to draw, let me see, this on a flat surface. So if you were to draw this, ooh, that's not very pretty. Would we say that it's skewed to the left or skewed to the right?
Positively skewed.
Which means skewed to the left or skewed to the right? Skewed to the right. Most of the data falls on the left, the tail is to the right. Yeah? Good. All right, we are moving right along. Okay. I'm not going to review much of this because you've seen it in elementary school. However, I'm going to talk to you about this analytical way of finding the median when you have large frequencies. Because so many of us are used to just writing them all out, putting them in numerical order, and then looking for the middle. That is not efficient, right? In mathematics, we want to be efficient. So here, the mean we consider to be the average. That is sometimes the best measure of center when you have symmetrical data. It is not the best measure of center when you have data that is skewed either left or right, positively or negatively, right? The median is the middle value of an ordered set. The mode is the most frequently occurring. Now, they say that you can find the median analytically using this formula. If there are n data values, you find the value of the median by taking the number of values that you have plus 1 divided by 2. So if you have 23 values among your data set and you want to find the median relatively quickly, then you can say, okay, 23 plus 1 is 24 divided by 2 is 12. If it's even, then it's the 12th ordered data point. Does that make sense? And here, if it's not even, if you have a decimal, then of course it's in between two. It's in between the 14th and the 15th in this case. All right? So go ahead and try this one on your own. If you have some basic number sense, this shouldn't be that hard, right? You know, this is your first value, that means this is going to be your fourth value. That means that to the 13th value, you're less than 9. The 14th to the 25th value is where you have 9, right? And you're looking for that 20th value. The reason you know it's a 20th value is that rule that I taught you. You take the total number of turns, which is 39 plus 1, or 38, sorry, 38 plus 1. I wrote that down wrong. 38 plus 1 is 39. Divided by 2 is going to give you that 19.5. That means it's going to be in between your 19th and 20th value. So 9 plus 9 divided by 2 is 9. Does that make sense? This is helpful because when you do your summative project and you deal with large data pools like we did at the very beginning, you're not going to have time to necessarily write an entire ordered list. So you can use this formula to help you find it. And again, this is one of those parts that I want you to write down analytically. All right. Questions? Okay. Here we go. This is the last bit of information. We talked about this already. This just reinforces. So, when you think about, and you know, in the States, in magazines and newspapers, I know this is true, I'm not sure how it is in other countries, but magazines are notorious for this, where they report that, okay, median is going to be our best measure, considered our average, so, you know, the average housing price is over this much, and so it's a great time to buy a house. When they're dealing with data that has outliers in it, okay, maybe they show you a list of housing prices and they have outliers in their data, which means that the mean or the average housing price isn't necessarily going to be that best measure of center. Because what's going to happen, again, it's going to pull here, when we have something skewed to the right, it's going to pull your mean to the right, which means your median is the best measure of center here, and the median is the best measure of center here. Does that make sense? All right, be prepared to discuss that within your own data. Any questions before we call it a day? No? Easy, straightforward, I hope? All right, your homework.